And so again, I'm just going to go through, and I know the middle ones are pi fourths. So if it helps you do it like that, like go not all around at once, get your pi fourths. So this is 3/4 of the way. And then after 5 pi fourths. And over here, we'll take 7 pi fourths. And you got to think about 8 pi fourths would be back to 2 pi. So that's kind of how you can think about where is that located. And then you got your pi 6. 30 degrees. 5 pi 6. 1/6 less than pi. 1 more than pi. 7 pi 6. 1 less than 2 pi, right? 11 pi 6. Because 12 over 6 is 2 pi. And all that's left are my thirds, which are my 60 degrees. Pi thirds. 2 pi thirds. 3 pi thirds is pi. 1/3 4. 4 pi thirds. 6 pi. 5 thirds. That's a part that I hope that that's sort of making sense to you. And then yesterday we added in the idea of these ordered pairs of what if we said this has a radius of 1, which means every single one of these lines that I have in here has a radius of 1. What would the ordered pair be that corresponds to that? And if you have a radius of 1, the 0, and the pi halves, right, that's just saying it's the x axis at 1 and the y axis at 0. So if you think about like on our normal coordinate plane, that's a really small circle, right? Like that's like 1, 1, 1, 1, and that's making that circle all the way around that. We've just kind of zoomed in so we can see it as well. So that makes up here, 0, 1, over here, 0, and down here, and then the big idea is saying, if we make the radius 1, what would my special triangle sides be? Knowing the ratios of a 30, 60, 90 are x, 2x, 3. What would the sides have to be if the radius is 1? And you don't have to know where this comes from, and you just memorize this. And that's where we ended yesterday. I kind of gave you that little hand trick, and I asked you to fill in the rest of this. So I'm just going to go through it one more time. Not the hand trick, the counting trick, but then I'll show you the hand trick too. So, what did I say? We start inside and we say 1, 2, 3. We go back to the top. We say 3, 2, 1. Everything's over 2. And then we take the square root of everything. And then you don't have to worry about where does it come from, because it just works. And we didn't actually evaluate any, which is what I have left to do on here. But the reason it's so amazing is because if you're in the unit circle, then every x and y correspond to the cosine and the sine of that angle, because we said that the cosine is just x now. So the x coordinate is just cosine. And the y coordinate is just sine, because it's y over r, and r is just 1. Which is pretty amazing, because that means that pi 6, if I know that ordered pair, I know the cosine of pi 6 is radical 3 over 2, and I know the sine of pi 6 is 1/2, without having to draw a triangle, without having to know the ratios, if I just know those ordered pairs. And what I encouraged you to finish is, if you know the first quadrant, you know the rest of the circle, because it's all just reference angles. So everything that is a 6, everything that has a reference angle of pi 6, which are going to be all the ones that have a 6 in the bottom of them, not even tricky, they're all going to be this exact same ordered pair. You've just changed the sign. So over here, I know it's just negative. And down here, I know it's negative. 3 over 2 negative. And over here, it's square root of 3 over 2 negative 1/2. Because I'm just looking at what quadrant I'm in and whether the x is positive or the y is positive. Because they're all reference angles, which is why it's all built on this. And it's the same for all of them. So I don't know if you need me to fill this in, if you haven't filled it in yet. But that's what you have to do. So some people, like, they really, the unit circle becomes, like, they have to have the whole thing to do a problem. So I give you a test, and the first thing they do is they draw the entire unit circle on. And if that's what you want to do, you can. But the idea is you don't really have to do that. Like, if you just know what the first quadrant is, then you can figure it out from there. You don't have to spend, 5 minutes or more drawing the whole thing out. But I feel like we could get really quick at doing this because we're just repeating ourselves. So all the force also have the same ordered pairs. You just change the signs for the quadrant. So in quadrant 4, that would be radical 2 over 2 negative 9 over 2. And in quadrant 3, they're always both negative. So negative 3 over 2. And in quadrant 2, negative 3. And the last one, I'm kind of way too big for this. The last one are the thirds, and all the thirds, which are all the ones that have a 3 at the bottom. So it's not, again, not even hard to see which ones go together, even if you don't know the idea about reference angles. All the thirds have the same ordered pairs. So, why did I consider this? Would be negative 1/2 squared root of 2. Now here, negative 1/2 negative squared root of 2. And over here, like I said yesterday, as we were finishing up on our very short lesson, I'm never going to require you to do this, reproduce it, but for a lot of people, it makes more sense than doing the triangles every time. I feel like it's less work than doing the triangles every time. I was never taught the unit circle. Like, we did radians, but like my teacher always taught us reference triangles, so I always do triangles. So I feel like I kind of lean that way more. The more I teach calculus, the more I get it. I get that it's not that hard to reproduce, and I can do the unit circle as well. All right, so that's the next step of, do I like the unit circle or do I like the triangles? And I can do questions both ways. So what we didn't get to yesterday is this. Let's evaluate these now using the unit circle. And if you use the triangles, I'm not going to mark it wrong. The same idea, I'll have to show you where it comes from. But the idea is, if you know the point, you can do this really easily. So, pi thirds, you've got to know where pi thirds is. So pi thirds is up here. If you know my shortcut, you know that we start with the 1 on the top. So once I know that, I know the first one is 1/2, and the second one is square root of 3 over 2. And if you know that ordered pair, then you can give me the trig function. So I just wrote 3. We could do all 6, but I did it. So notice theta is not in this problem right now, right? So if you were going to write this correctly, you have two options here. You could write sine of t, because it says t equals pi thirds. Or you could just say the sine of pi thirds. Right? Theta is kind of like our go-to, just like x is our go-to in algebra. But if x isn't in the problem, right, you're really supposed to keep the letter that's there. So let's keep that in mind. Here's why people love it. The sine is y over r. R is 1. The sine is just the y coordinate. So if I know that ordered pair, I don't have to do any work. The sine the cosine you got to know these ratios. You got to know cosine is x. We said x over r, but now it's just x because r is 1. So the cosine is just 1/2. And then what about tangent? We have to learn the word for tangent. I'm going to show you a great thing about that. Pretty good for tangent. Y over x. So y is radical 3 over 2, or y is sine, cosine is x. So if I did that, I would get radical 3 over 2 over 1/2. That just looks gross, right? That's what people say. I'd rather do the triangles because that's terrible. But they're always both over 2. And I'll show you where this comes from. That every time if you work this out, those denominators are just going to cancel. Which means you can just take the top of the y over the top of the x. And it always works, because when we divide by fractions, right, I'll show you where this comes from. I'm not going to make this after. Dividing by fraction is the same as multiplying by the dividing by 1/2 is the same as multiplying by 2/1. Every time it'll cancel. So you can actually do the work. You can just know that the denominator is going to cancel. So the answer there is just square root of 3. Just to show you real quick, if you want to do it the other way, to me it's about the same amount of work. You got to memorize the circle, or at pi-thirds you have to know this is 60 degrees, and you go back to the old school way. Like the ratio of the sides of a 60-degree angle is, say the shortest side is 1, this is 2, this is square root of 3. And you're going to get the sine is opposite over adjacent. It's square root of 2. The cosine is 1/2. Tangent is square root of 2. It's the same answer. It's just kind of two ways of doing it. So just which one you want to do. So let's do a special angle now. Pi. What's the ordered pair for pi? Yeah, pi's over here, so it's -1, 0. This is where I think the unit circle is better, because you can't draw a triangle when one of the corners is 0. You can't make a right triangle out of it. So you have to know the ratios. So you have to be able to do it on this one, or use the whole like -x to 0. Again, you should be saying tangent of pi, sine of pi, or sine of t, cosine of t. And what's the sine of pi going to equal? Sine is the y-coordinate, and the y-coordinate is 0. I don't have to do Pythagorean theorem. I don't have to think about a picture. I can just know sine is the y-coordinate. Cosine is the x-coordinate, so the cosine of pi is always -1. And what's the tangent of pi going to be? 0, because tangent is y over x, so 0 over -1 is 0. Think about some of the other ones. If we did all 6 here, cosecant would be undefined, because now 0 would be on the bottom. Cotangent would be undefined, because 0 is on the bottom. But if we're just doing these. Okay, so pi-thirds pi, those are on my unit circle that we filled out. Well, what about number 3? -pi6 is not on my unit circle. So how do I do it? You could just say, where is -pi6? It's just going the other way. So instead of going up pi6, I would go down pi6. Is that angle on my unit circle? Yeah, it's the same as 11 pi6. It's just going the other way. So you have to know -pi6 means go the other way, and it would be that ordered pair. So just like we talked about before with negative angles, you can actually graph the negative angle. If you don't like negative angles and you want to go the positive way, what could I do to make this a positive angle? I can add 2 pi to it, and if I did that, I'm going to get 11 pi6, which is just the exact same place, only going positively. So again, you have options here which way you're more comfortable working with it. But either way, you should end up at this ordered pair. And again, for me, I don't make the whole circle. I think about what the angle is up here, and then I just move it down here. So if you think about the one we just did, pi-thirds, we started at 1, that was 1/2. So I always know this one is the other way around. It's square root of 3 over 2 1/2. Which means this is square root of 3 over 2 negative. So you got to get your signs right, positives and negatives. So now we can do this. And you just have to know these ratios. Sine is y, cosine is x. So the y coordinate is now -1/2. The x coordinate is square root of 3 over 2. And the tangent, what's the ratio for tangent again? Y over x which means if you just do the shortcut of knowing that the 2's kind of just go away, it's just -1 over the square root of 3, which again, I'm okay if you want to leave it like that, or that's the same as if you rationalize it, you would get negative radical 3 over 3. So I want to show you a little hand trick for a minute, just not again that you have to do it, and I think it's kind of silly, but some people like it. Chloe Carter still uses it when she does these, so it only works for the first quadrant though. So it works out really well, because if you think about your hand a little bit, this is like your x-axis, this is half, so notice you have 3 fingers in the middle there, so it'd be like your pi fourths, and your pi thirds. So here's the part that's kind of weird about it. You have to imagine the 2, right? Because the 2's not the bottom part. You have to know they're all over 2. So that you have to pretend that there's a 2 underneath. Some people say, well, you have to pretend there's a 2 underneath. Let's say you wanted to look at the order pair for pi 6. So in the pi 6, so I pull my finger in, and the top, like that, is like your x coordinate. And the bottom number is your y coordinate. So this is your square root of 3 over 3 is the square root of 3 over 2. And the y coordinate is pi fourths, radical 2 over 2, 2 over 2. Pi thirds, 1 half, radical 3 over 2. If you want to get really crazy, what's the tangent of pi thirds? You can flip your hand over, and the 2 goes away, and it's just radical 3 over 1. I was at a conference and he showed us that, and he said his first principal came in and observed him in his pre-cal class, and said they were all doing this thing, and he wrote on his evaluation, and he said, but it works, and it's a way that if you forget what comes first, it's radical 3 to 1 half. Last year I didn't show them until I didn't show them until way later, and then when I showed some people, they were really upset that I didn't show them coordinate hands because it made sense to them. I don't use the hand trick, I have to really think about it sometimes, but that's hand trick. Do you have other questions about this or about the other homework from yesterday that we kind of buzzed through the questions yesterday over that? Like the end ones, I didn't do any of those, of like where they gave you one and asked you to find the other ones. Okay, put everything away. That has extra credit. It's supposed to be a good kid. It will be like please, you can't use your